Hey everybody, Vade here. Today we are going to be figuring out what is the square root of I. So just a warm up here, what is the square root of 2025? That's right, it's just 45. It's a good year for math competitions. Anyway, so if you are higher up in the realm of math, you probably know that a quick and easy way to do this is just to use de Moivre's theorem. If you have no clue what I'm talking about, then continue watching. If you do, then still continue watching. And if you recognize the method that I'm using, maybe still watch to see how it's fully done, or just stop watching because it's like, okay, I already know this is not new, not interesting at all. Anyway, so we know that any complex number, right, is in the form a plus bi, right? And so remember, a complex number, a real number is a complex number, and an imaginary number is also a complex number. So you're probably like, how is a real number ever going to fit this form? Well, remember, b can be 0. So if we wanted to represent 2 in the form of a complex number, we would just do 2 plus 0i, right? This is why 2 is a complex number, or a real number is a complex number. It's because it can be represented in this form. So we know that if this is an imaginary number, right, I is imaginary number, right, the square root of an imaginary number should still yield an imaginary number, right? And an imaginary number is a complex number. So therefore, we can say that the square root of I has to fit in the form a plus bi, right? And so now what we're going to do then is just square both sides here. So then we'll get I equals to a plus bi whole squared. And then we can distribute here, so we get a squared plus 2abi plus bi squared. So then I will then equal to a squared plus 2abi plus b squared I squared. And remember, I squared, that's just -1, because if I equals the square root of -1, square both sides, I squared equals -1. So then we'll get I equals to a squared plus 2abi minus b squared. And so now what we want to do is we kind of want to split up the real parts and the imaginary parts. So what I mean by this is, if we have I, we could put it in complex number form 0 plus I, right? A is 0, B is 1. Then we can rewrite this as a squared minus b squared, right? This will just be a constant, right? A real number, plus then our imaginary, which is 2ab times I. And so now we can then set up a relationship here. We can equate this 0 with this, and we can equate this I related term with this, right? So we can then say that a squared minus b squared equals 0, and then 2abi equals I. Okay? And so then we can say here, a squared must then equal to b squared. And then we can also say here that we can cancel out the i's here. 2ab must equal to 1. And so now it's just a system of equations. So I'm going to deal with this equation first and isolate a and isolate b. So for a, we'll get a is equal to b over 2. Or no, not b over 2, 1 over 2b. And then b is equal to 1 over 2a, right? And so now what we can do here is substitute these into this equation. So I'm going to substitute for the a here to solve for the b. So we'll have 1 over 2b squared equals b squared. So then we'll have 1 over 4b squared equals b squared. And then we'll have 1 equals to 4b to the fourth. B to the fourth equals 1/4. So then we'll have b equals plus or minus 1 over the fourth root of 4. And we can actually simplify the fourth root of 4 here, because remember, the fourth root of 4 is just 4 to the 1/2. And remember, 4 is just 2 squared, so that's 2 squared to the 1/2. So then that's just equal to, to the 1/4. To the 1/4. And this will then equal to 2 to the 1/2, which is just square root of 2. So we'll have plus or minus 1 over square root of 2, which we can also rewrite as plus or minus root 2 over 2. Okay, and then now for our a, or we want to solve for a, so we can plug in this. So then we'll have, here we'll have a squared equals to 1 over 2a squared. And hopefully you realize here that we're just getting this same equation here, right? And so if we got b equals plus or minus root 2 over 2, a should also equal that, because this equation is in the exact same form as the other one with the b. So since I'm going to write here just to make it clear, since this is in the form of 1 over 2b squared equals b squared, and b equals plus or minus root 2 over 2, a must equal to plus or minus root 2 over 2, since it's also in the same form. So now, if we think about, right, if b equals to plus or minus root 2 over 2, and a equals plus or minus root 2 over 2. And remember, the standard form of a complex number here is a plus bi, and if square root of I equals a plus bi, we can just plug in our a's and b's. So one possibility here, the square root of I, it could equal to root 2 over 2 plus root 2 over 2i, right? It could also equal to negative root 2 over 2 minus root 2 over 2i. And then we could have some sort of alternating here, like root 2 over 2 minus root 2 over 2i. Or then we could have also a negative root 2 over 2 plus root 2 over 2i. And just to check that this actually works here, if we do something like square root of I equals to, negative root 2 over 2 plus root 2 over 2i, and then square both sides, we can then see that I would then equal to the square of this. So we can just use a plus b the whole squared. So this could just be negative, or root 2 over 2 squared plus 2 times negative root 2 over 2 times root 2 over 2i plus root 2 over 2i squared. So then this will then be 2 over 4 plus 2 times negative 2 over 4i plus 2 over 4i squared. So then this will then be 1/2 minus 4 over 4i minus, and then remember I squared is negative 1, right? We'll have 1/2 minus 4 over 4i, and this would be minus 1/2. And so then we'll have negative I. Okay, and so here we see that I equals negative I, which is not a true statement. So this is actually an extraneous solution. And then if we try this here, it'll also be an extraneous solution. Okay, so I'm just going to say at the time and tell you that this is also an extraneous solution. So really, the square root of I is root 2 over 2 plus root 2 over 2I and negative root 2 over 2 minus root 2 over 2I. So hopefully you learned